Okay, good morning, students. Today we're going to continue with our lesson 2. Here today we will briefly explore programming paradigm. It's one of the subtopics in this course, Survey of Programming Languages. Well, paradigm as the terminology we normally use simply means the style of writing. The different style of writing is not a language, is just a pattern of writing. And here we have different paradigms. Here in this class, I classified them into two major types: imperative language paradigm and declarative language paradigm. Under imperative, we have procedural programming paradigm, object-oriented programming paradigm, parallel programming paradigm. Whereas under declarative, we have logic programming paradigm, functional programming paradigm, database programming approach. Python as the primary language we are going to use to demonstrate all the concepts of this we are going to be taught in this class is a multi-programming paradigm, or it adopts multiple paradigms. You can write Python as a functional language. You can write it as a style of functional language. You can also use an object-oriented style. So there are so many other languages that adopt a multi-programming paradigm. So imperative programming paradigm, of which style is this programming languages that adopt this pattern? How is it written? How will you just explain it to a layman? Well, we know that this is the earlier or the oldest paradigm that was introduced. It simply focuses on describing how a program operates, how you specify the step-by-step instruction for computer to perform your task. Of course, you know that programming are the way we instruct computer to perform different functions. Procedural programming paradigm, this style organizes code into reusable blocks called function. You arrange it in what we call sub-procedure. Earlier before now, functions are regarded as sub-procedure, which can be called within the program where it is needed. For instance, if you want to greet people, you can create a function to generate a greeting or use it for different names. Example, a function that greets multiple people by looping through a list of names. We are going to understand this better with a Python code illustration. Then object-oriented programming paradigm. You all know about object-oriented programming. This style structured program using objects which combine data. Data is known as attributes, and action. Action in object-oriented program is known as method. It is like creating a blueprint, which is a class for an object, and then making instances of it. So object-oriented programming emulates real-life scenarios, and those real-life scenarios are encapsulated as a class, which we know as the blueprints of object-oriented programming language, and we use object to instantiate our class, and that is why we say that object is an instance of a class. We explain it better in the course of this class. Um, we look at a simple example, a class that defines a greeter object, where each object can greet someone with their names. You understand this better with an illustration, which we are going to look into very soon. Parallel programming approach. This style runs multiple tasks at the same time to save time and resources. It is like cooking multiple dishes on a separate burner simultaneously. So this is what the concept that was introduced in multi-programming concept. You know, these days, unlike before now, you can operate or use different applications at the same time. So this is a concept that is introduced to enable such. In those days when we are in school, when we were using Windows 97. In those days, you can only enter the window through DOS prompt. The system will boot into DOS prompt. All you need to do is just type win. When you type win, it will now bring you to window environment. So in the world of single tasking operating system, you cannot use two applications at the same time. So this parallel processing approach was introduced to enable us enjoy what we are enjoying in this present time, where you can be on a system and multitasking. So it will get clearer too when we demonstrate it practically. Example, processing tasks like task 1, task 2, and task 3 at the same time. So the declarative language paradigm. These paradigms focus on describing what the program should accomplish rather than how to do it. That is what we are told. So we'll examine it under logic programming. This approach focuses on defining rules and relations, letting the program figure out the answer. It is like giving a puzzle to solve without describing every step. Example, finding all possible arrangement of items, like in permutations. Functional programming paradigm. This style emphasizes using pure functions that avoid changing state. So it is mutable. You cannot change the state of the data within the program. It is like creating formulas in a separate sheet, and each function does one thing and does not affect the other. Example, squaring a list of a number or filtering out even numbers without changing the original list. We are going to understand it better with programming example, data-based programming approach. This approach focuses on storing and retrieving structured data using queries. It is like organizing data in tables and then asking specific questions to get an answer. Example, creating a table of students, adding data and retrieving all student records using SQL query. So we look at different sample programs to demonstrate this. This Python good example for demonstrating programming paradigms. Here, you can see a typical example of imperative programming, that is procedural programming. You look at the Python code that define a function and also return the function, and you see the names are passed through that different names are passed through the names, and when you call this particular function, it will give you results. So this sample program demonstrated object-oriented programming. This one demonstrated parallel processing approach, and this demonstrated logic programming paradigm, and this demonstrated functional programming paradigm, whereas this demonstrated the database programming paradigm. I think I have a book I compiled in Python programming. That book is very, very good for both beginners and the intermediate or professional programmers. For those that have it, you can go and learn how to install IDE. Those that don't have it, you can go online and find some resources to help yourself understand this Python programming. So if you look at this book, if you want to base on this book to show our demonstration of how to install this, you can use any IDE. You can use any IDE, but I prefer this book. You see, I described it step by step. You can hardly see this book written anywhere. You cannot see the concept or approach I use this book anywhere, because I use it in such a way that even somebody in primary school can just learn on his own. And I have demonstrated that with my children in primary school. They're using it without even calling my attention. So you see, I discussed step by step how you are going to install Python. The first thing you need to do is to install Python. Python must be installed, following the step. You can also go online to find the step for installing Python. You can use any IDE. Here I describe how you can install VS Code, PyCharm, and also the inbuilt IDE that comes with Python when you install it. But the reason why I prefer Jupyter Notebook is what I'm going to show you now. That is what I use in training my model when the data set is very, very small. But when I have a large data set, I leverage the crowd. You can use Google Colab or AWS uh, 1 year version, but Colab can do a lot of things, unless when the data set becomes so large. So here I'm not going to spend my time to show you how to install it. The step is written in this book or in any online resources you can get. So, but I already have a Jupyter notebook in my system. I want also use it to demonstrate this code here. All you need to do is, if you have installed Jupyter Notebook, this book will show you how you can install it without even bothering to install Anaconda in your system. It's just simple using pip install, you get it done. I have it already. All you need to do when you have installed the Jupyter Notebook is to go to your command prompt, and type Jupyter Notebook. Jupyter Notebook. It will simply open it in your browser. As you can see here, is opening it. Okay, you can see my Jupyter Notebook. So all you need to do is you can go to the desktop and create a folder where you want to store your code. Here I have already created a folder that I call CSC401 code. You have to open it. I have already created some code where I run this sample Python code to demonstrate the paradigm. But you can see, you can still open a new one. If you want to open a new notebook, you just have to go here. You just have to go here. You can see, you go here, you click on new, click on notebook. It will open a new notebook for you. So here you just select, it's only Python 3. You select the Python, it's non-name, you can give it a name. You can give it a name by double-clicking to open this. You give it a name, we can call it a programming paradigm. Programming paradigm. Paradigm. You rename. So this is your notebook. So all you need to do is you get your code. You don't need to waste our time here, start typing the code afresh. You can just go get your code and run it in each cell. The good thing about this thing is this thing will store your code each cell. You can in each cell, and you can always come back to reference it. So you can see that this is a function. This is we define a function. We have another function to define the names. We return this function with hello, so that when you say hello, when you pass the name, it will just say hello, the name. So this is where we pass the name statically, and when you call upon this procedure, it's now give you hello, the name you pass here. So you can see how this program is being run. We run each of the procedure. This one is an object-oriented demonstration. You run your code. You also run. You see that it's the same thing. It's doing the same thing, but written in different style. That's why we're saying that it is a style of writing. You see that here the program is define a class. This is a blueprint. You have different methods. The method is instantiated here. This is an object. You call it up here. You interact. That's loop it here, then and now have your result. So what we are demonstrating is different style of writing a programming segment or programming procedure or subroutine, but they all do the same thing, but in different style. So the style of writing depends on the task at hand. The task at hand will determine the style you want to use to write it. If the style at hand is a complex program, it is good to use object-oriented program because it will help you arrange your tasks that even in the nearest future, it's not going to be a problem to update that program. All you need is to start adding your classes and begin to call it up when it is needed. So this one demonstrated logic programming, and this is a concept that is used in building these libraries, because we are able to run some of these programs because there are inbuilt libraries that is being called upon for a particular program to execute. We are going to see it here. This is a functional program. You see we have a function square. When it's called upon here, it was able to execute. So it's immutable. When we get to the concept of okay, let's look at this critically. Let's look at okay, let's continue running the program. I will now show you something under uh, database programming. So in database programming, you see here that we import SQLite 3. So this is a library. This library has different functions. It has different functions that is within this Python program, but it is just created and put in the library as a different classes in a module. So because you don't need to start writing all the connection of this database afresh. All you need to do is to just import the library, and this is what exactly this import statement is doing. So this concept of creating modules and all classes has really helped the world in building complex programming languages, and this is what is enabling us in this complex world of programming, that we can have different applications that have been created in previous years, but now all we need to do is to keep on updating. As the world is improving, the activities of our organization are also improving, and the cause for need for us to be updating existing application. And through the help of this uh, object-oriented procedure or object-oriented paradigm, we can easily update existing application as easy as possible. And as we continue in this class, we will continue to demonstrate and see the reality of these paradigms as we write some simple projects along the line in this class. I think I have passed a brief message of what programming paradigm is all about, and we have just demonstrated how you can use your Jupyter notebook to demonstrate that. So as I've written this program here, you see that anytime you come, any day, you come back and come to your Jupyter notebook and see it here. As the program is running in DOS prompt, you can just finish and close your DOS prompt, and it closes. When you come next time, you will just type Jupyter notebook in the DOS prompt, it comes out. You open your desktop, open your code, you continue to write. So as I've written as many programs as possible and you have trained as many models as possible, you can refer back to a particular program you have written. If you want to use it for subsequent code, it will be easier for you. That's why I recommend people, especially beginners, to use Jupyter Notebook. Thanks for listening.